last class we discussed about relative lowering of vapor pressure, then some mathematical expression to calculate molar mass of a non-volatile solid using relative lowering of vapor pressure, right? So there we already discussed one very important point. Uh, if you add a non-volatile solid to volatile solvent, its vapor pressure decreases, right? When if you add a non-volatile solid to volatile solvent, its vapor pressure decreases. So now we'll go for next colligative property, that is elevation in boiling point. Okay, elevation in boiling point, nothing but increase in boiling point. Okay, increase in boiling point. Okay, increase in boiling point. Okay, so you know, if you add a non-volatile solid to volatile solvent, its vapor pressure decreases, right? So then we'll go for one relation between vapor pressure and boiling point. Okay, you already know boiling point of a liquid, boiling point of a liquid is inversely proportional to vapor pressure, right? Boiling point of a liquid is inversely proportional to its vapor pressure. So then if you add a non-volatile solid to volatile solvent, then vapor pressure decreases, right? Vapor pressure decreases. If vapor pressure decreases, then what happens to boiling point? Boiling point should increase. Okay, that is the relation between vapor pressure and boiling point. Okay, we have four colligative properties. In all that four colligative properties, we have one common term. That is, if you add a non-volatile solid to volatile solvent, vapor pressure decreases. Based on that point, that is a decrease in vapor pressure, that will decide the other properties. Okay, so here if you add a non-volatile solid to volatile solvent, then vapor pressure of the solution decreases. So since vapor pressure decreases, boiling point of the solution increases. Okay, because vapor pressure and boiling point are inversely proportional to each other. Okay, due to decrease in vapor pressure, boiling point of the solution increases. Okay, later once again we'll discuss that factor. Before that, we'll discuss what is boiling point actually. What is boiling point actually? Simple definition is temperature at which liquid converted into vapor, right? Temperature at which liquid is converted into vapor. Normally we are calling that temperature as boiling point, right? But actual definition of boiling point, what it says, temperature at which vapor pressure of liquid, or we can write definition, boiling point is nothing but temperature at which boiling point, sorry, vapor pressure of liquid vapor pressure of liquid becomes equal to atmospheric pressure. Okay, that temperature is called boiling point, right? Temperature at which vapor pressure of a liquid become equal to atmospheric pressure. Okay, when if you take a liquid, if that liquid is volatile, then we have one characteristic property called vapor pressure. Then when vapor pressure of a liquid substance become equal to its atmospheric pressure, in atmosphere one particular pressure. Okay, when vapor pressure of the liquid become equal to atmospheric pressure, that temperature, right, at one particular temperature, that vapor pressure of the liquid become equal to atmospheric pressure, that temperature is called as boiling point. Okay, so if you draw a float of temperature versus vapor pressure, if you draw a float of temperature versus vapor pressure of a liquid, now this one is now atmospheric pressure 1 atm, that is atmospheric pressure. Okay, normal at sea level, atmospheric pressure is 1 atm. Then, if you take any particular liquid, this one is vapor pressure curve. As temperature increases, vapor pressure also increases. Okay, you can observe as temperature increases, vapor pressure of liquid also increases. Then at one particular temperature, okay, that will vapor pressure of the liquid become equal to atmospheric pressure. This one is atmospheric pressure. 1 atm is atmospheric pressure. You can observe at one particular temperature. I'll take it as T1. Okay, take it as T1. At T1, vapor pressure of the liquid is equal to atmospheric pressure. Okay, then T1 is considered as the boiling point of the liquid. Okay, when vapor pressure of the liquid become equal to atmospheric pressure, that temperature is called as boiling point. Okay, here ಈಗ ಲಿಕ್ವಿಡ್ ತಗೊಂಡ್ರೆ ಲಿಕ್ವಿಡ್ ಒಂದು ವೇಪರ್ ಪ್ರೆಷರ್ ಇರ್ತದೆ. ಓಕೆ, ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆದಾಗೆ ಲಿಕ್ವಿಡ್ ನ ವೇಪರ್ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಹೋಗುತ್ತೆ. ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ಅಟ್ಮಾಸ್ಫಿಯರಿಗೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಇರ್ತದೆ. ಮಾಮೂಲಿ ಸಿ ಲೆವೆಲ್ ತಗೊಂಡ್ರೆ ಸಿ ಲೆವೆಲ್ ಅಲ್ಲಿ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ 1 atm. 1 atm ಇಸ್ ದಿ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್. ಈಗ ಲಿಕ್ವಿಡ್ಗೆ 1 atm. ಈಗ ನಾರ್ಮಲಿ ವಾಟರ್ ತಗೊಂಡ್ರೆ ಎಟ್ 30 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ವಾಟರ್ನ ವೇಪರ್ ಪ್ರೆಷರ್ 1 atm ಆಗಿರೋದಿಲ್ಲ. Okay, that is less than 1 atm. Then you have to increase the temperature. Water na temperature ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದಾಗೆ vapor pressure of water increases. At 100 degree Celsius, 100 degree Celsius ಆಗುವಾಗ, okay, at sea level ಅಲ್ಲಿ ನೀವು ವಾಟರ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಿ. 100 degree Celsius ಗೆ ಟೆಂಪರೇಚರ್ ರೀಚ್ ಆಗುವಾಗ vapor pressure of water become equal to 1 atm. ವಾಟರ್ ನ vapor pressure 1 atm ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಓಕೆ, 1 atm ಆಕ್ಚುಲಿ ಏನು, ಅಟ್ಮಾಸ್ಫಿಯರ್ ನ ಪ್ರೆಷರ್ 1 atm ಉಂಟು. ಟೆಂಪರೇಚರ್ 100 ಡಿಗ್ರಿಗೆ ರೀಚ್ ಆಗುವಾಗ ನಿಮ್ಮ ವಾಟರ್ ನ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಾಗುತ್ತೆ 100 ಡಿಗ್ರಿ 1 atm ಗೆ ರೀಚ್ ಆಗುತ್ತೆ. ಸೊ 100 degree Celsius is the boiling point of the water because at 100 degree Celsius vapor pressure of water become equal to atmospheric pressure. Okay, so we are calling 100 degree Celsius as boiling point of water at 1 atmospheric pressure. Okay, sea level ಅಲ್ಲಿ 1 atmospheric pressure ಇರ್ತದೆ. 1 atm pressure ಅಲ್ಲಿ boiling point of water is 100 degree Celsius. 100 degree Celsius because ನೀವು ವಾಟರ್ ಅನ್ನು 100 degree Celsius ತನಕ ಹೀಟ್ ಮಾಡಿದಾಗ ಅದರ ವೇಪರ್ ಪ್ರೆಷರ್ 1 atm ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಎಸ್, ರಿಮೆಂಬರ್ ದಟ್ ಪಾಯಿಂಟ್. ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್? ಓಕೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ is nothing but temperature at which vapor pressure of liquid become equal to atmospheric pressure. Okay, so now we'll go for a solution of non-volatile solute in volatile solvent. Okay, now you know boiling point is inversely proportional to vapor pressure. So now if vapor pressure of liquid is high, then its boiling point is low alwa. ವೇಪರ್ ಪ್ರೆಷರ್ ಲಿಕ್ವಿಡ್ ಇದು ಜಾಸ್ತಿ ಇದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಲೋ ಇರ್ತದೆ, ಲೋವರ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಬಾಯ್ಲ್ ಆಗ್ತದೆ. ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ಇಸ್ ವೆರಿ ವಿಚ್ ಒನ್ low, then its boiling point is very high. Now if you compare ethanol and water, okay, vapor pressure of water is somewhat lower than that of ethanol. Water ಮತ್ತು ethanol ಅನ್ನು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ water is less volatile, ethanol is more volatile. So ಯಾವುದು ಲೆಸ್ ವಾಲಟೈಲ್ ಇರ್ತದೆ its vapor pressure is low, ಯಾವುದು more volatile ಇರ್ತದೆ ಅದರ vapor pressure high. So now if you compare the boiling point of ethanol and water, boiling point of ethanol is lower than that of water. Okay, boiling point of ethanol is lower than that of water. Water in a boiling point ಜಾಸ್ತಿ 100 degree Celsius, ethanol boiling point less than 100 degree Celsius. Prepare a solution of non-volatile solute in volatile solvent. Okay, non-volatile solute in volatile solvent. Now initially solvent is volatile, it has one particular vapor pressure. Okay, then if you mix a solvent with the solute, We already discussed, if you add a non-volatile solid to volatile solvent, vapor pressure decreases, right? Vapor pressure of the solution decreases. Clear, right? If you add a non-volatile solid to volatile solvent, vapor pressure decreases. Then go for this relation. Boiling point is inversely proportional to vapor pressure. Here, vapor pressure decreases. So what happens to boiling point? Boiling point will increase. Okay. So that is a simple relation between vapor pressure and boiling point. Okay. So that colligative property is called as elevation in boiling point. Okay. If you add a non-volatile solid to volatile solvent, vapor pressure of the solution decreases. Because of that reason, boiling point of the solution increases. Okay, we'll discuss what is the meaning of increase in boiling point. Okay, that is not increase in boiling point of the solution. We are comparing boiling point of pure solvent with that solution. Okay, let's discuss that point. What is the meaning, actual meaning of elevation in boiling point? Okay, so remember that point. If you add a non-volatile solid to volatile solvent, vapor pressure decreases. Okay, yes. Now let TB naught by the boiling point of solvent. Okay, boiling point of the solvent. TB naught is the boiling point of the solvent. Then take a TB as boiling point of the solution. Boiling point of the solution. Okay, let TB naught be the boiling point of the pure solvent. TB be the boiling point of the solution. TB be the boiling point of the solution. Then clearly says, already we discussed the definition. If you add a non-volatile solid to volatile solvent, boiling point increases. Agar ನೀವು ಸಾಲ್ವೆಂಟ್ ಮತ್ತು ಸೊಲ್ಯೂಷನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಯಾವ್ದಾರ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಇರ್ತದೆ? Boiling point increases when if you add a non-volatile solid to volatile solvent. Solvent ಗೆ ಒಂದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇರ್ತದೆ. ಆ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ ಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಅಮೌಂಟ್ ಆಫ್ volatile solid add ಮಾಡುವಾಗ ಅದರ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. Okay, solid if you mix solid with solvent, that will clearly says boiling point of the solution is greater than that of the solvent. Boiling point of the solution is greater than that of the solution, right? So we can write increase in boiling point. So if you add a non-volatile solid to volatile solvent, boiling point increases. Okay, boiling. So now if we compare the boiling point of the pure solvent in the solution, we can write like this. If you add a non-volatile solid to volatile solvent, then boiling point of the solvent is lower than that of the solution, right? Boiling point of the solvent is lower than that of the solution. Okay, we can take that difference delta TB. Okay, delta TB, that is elevation in boiling point. Okay, delta P is called as elevation in boiling point. Okay, elevation ಅಂದ್ರೆ ಏನು? Increase in boiling point ಅಷ್ಟೇ, ಬೇರೆ ಏನಲ್ಲ. Increase in boiling point, that is equal to, ಈಗ we have two boiling point ಅಲ್ವಾ, TB naught ಮತ್ತೆ TB ಯಾವುದರ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರ್ತದೆ? TB or TB naught? TB is more than that of the TB naught. While taking delta TB, you have to take TB minus TB naught, because boiling point of the solution is more than that of the solvent. Okay, solution boiling point TB, that is more than that of the solvent. Delta TB equal to TB minus TB naught. Okay, so you can write elevation in boiling point, that is equal to elevation in boiling point, that is equal to boiling point of the solution minus boiling point of the solution minus boiling point of solvent. Boiling point of solution minus boiling point of the solvent. This is actually the meaning of elevation in boiling point. Okay, clear? ಇದು elevation in boiling point in the meaning. So if you add a non-volatile solid to volatile solvent, then boiling point of the solution is more than that of the pure solvent. That is because if you add a non-volatile solid to volatile solvent, its vapor pressure decreases. Since vapor pressure and boiling point are inversely proportional to each other. Okay, so as vapor pressure decreases, boiling point increases. Okay, that magnitude of increase in boiling point is referred as elevation in boiling point. Okay, ಎಷ್ಟು increase ಆಗ್ತದೆ ಡಿಫರೆನ್ಸ್ ಉಂಟಲ್ಲ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ ಮತ್ತು ಸೊಲ್ಯೂಷನ್ ಎಷ್ಟು ಡಿಫರೆನ್ಸ್ ಸೊಲ್ಯೂಷನ್ ಮೈನಸ್ boiling point of the solution minus boiling point of the solvent, that value will give the idea about what is the magnitude of increase in boiling point. Okay, yes, it's about elevation in boiling point. Okay, next we'll go for graphical representation. Graphical representation of elevation in boiling point. ಇಲ್ಲಿ ಬರೆದ ಫಾರ್ಮುಲಾವನ್ನು ಗ್ರಾಫ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. Just float a graph of temperature versus vapor pressure. Okay, temperature versus vapor pressure. Plot of temperature versus vapor pressure. Okay, then take it as atmospheric pressure. Dotted line indicates the atmospheric pressure. 1 atm ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ, that is 1 atm. Okay, atmospheric pressure 1 atm. Dotted line atmospheric pressure ಅನ್ನು ಇಂಡಿಕೇಟ್ ಮಾಡಿದ್ದು 1 atm. Okay, 1 atm is the atmospheric pressure. Okay, then draw the float of vapor pressure versus temperature for pure solvent. ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ಗೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಮತ್ತು ಟೆಂಪರೇಚರ್ ಫ್ಲೋಟ್ ಮಾಡಿ ಏನಾಗುತ್ತೆ, ಆಸ್ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. ಓಕೆ, ಸೊ ವಿಲ್ ಗೆಟ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಕರ್ವ್ ಲೈಕ್ ದಿಸ್, ರೈಟ್. ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಹೋದಾಗೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಹೋಗ್ಬೇಕು. ಓಕೆ, ದಿಸ್ ಪಾಯಿಂಟ್, ರೈಟ್, ದಿಸ್ ಇಸ್ ಫಾರ್ ಸಾಲ್ವೆಂಟ್. ಓಕೆ, ದಟ್ ಇಸ್ ಫಾರ್ ಸಾಲ್ವೆಂಟ್. ಓಕೆ, ವಾಟ್ ಇಸ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಆಕ್ಚುಲಿ? ಈ ಪಾಯಿಂಟ್ ಏನು? Vapor pressure equal to atmospheric pressure. What is that point called? That point is called as boiling point, right? Boiling point of the solvent. So that point indicate, we can write it as TB naught. Okay, that is TB naught. That point is referred as solvent ಗಿಂತ ಕೆಳಗಿರಬೇಕಾ? Imagine, yeah, this is vapor pressure versus temperature curve for pure solvent. Okay, then ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ಗೆ ಆಡ್ ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲಿಡ್. ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲಿಡ್ ಆಡ್ ಮಾಡುವಾಗ ಏನಾಗ್ತದೆ, ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸಸ್. ಸೊ that curve of vapor pressure was temperature, that is below the vapor pressure temperature curve for pure solvent. Okay, vapor ಸಾಲ್ವೆಂಟಿನ ಕರ್ವ್ ಗಿಂತ ಕೆಳಗೆ ಬರಬೇಕು, ಯಾಕಂದ್ರೆ ಸಾಲ್ವೆಂಟಿನ ವೇಪರ್ ಪ್ರೆಷರ್ ಸೊಲ್ಯೂಷನ್ ನ ವೇಪರ್ ಪ್ರೆಷರ್ ಗಿಂತ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಸೊ as temperature increases, again vapor pressure increases, right? This one is for solution. Okay, this curve is for solution, that curve is for solution. Okay, it is solvent curve, vapor pressure versus temperature curve for solvent. At this point, that is referred as TB naught, the boiling point of the pure solvent. Then solvent you are adding non-volatile solute. Non-volatile solid add ಮಾಡುವಾಗ ವೇಪರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಇರ್ತದೆ. ಸೊ ಸೊಲ್ಯೂಷನ್ ನ ಕರ್ವ್ ಸಾಲ್ವೆಂಟ್ ಕರ್ವ್ ಗಿಂತ ಕೆಳಗೆ ಇರ್ತದೆ. ಓಕೆ, ದೆನ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ at this temperature vapor pressure of the solution become equal to atmospheric pressure ಅಲ್ವಾ? ಈ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ, ಸಾರಿ, at this vapor pressure of the solution become equal to atmospheric pressure. So that point is nothing but boiling point of the solution. ಆ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಬಾಯ್ಲ್ ಆಗ್ತದೆ, ಆ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಬಾಯ್ಲ್ ಆಗ್ತದೆ, ದಟ್ ಇಸ್ ಟಿ ಬಿ. ನಾವು ಕ್ಲಿಯರ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಟಿ ಬಿ ನಾಟ್ ಮತ್ತೆ ಟಿ ಬಿ, ವಿಚ್ ಒನ್ ಇಸ್ ಹೈಯರ್? Higher, that is TB is higher than that of the TB naught. Boiling point of the solution is more than that of the solvent. Okay, what is the factor? Deciding factor is vapor pressure. Okay, vapor pressure is the deciding factor, right? Okay, now there's a difference ಈ ಎರಡು ಕರ್ವ್ನ ಡಿಫರೆನ್ಸ್ ತಗೊಳ್ಳಿ, ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿಸ್ TB and TB naught, right? That is called delta TB. That is called delta TB, okay? That is called delta TB. So we can write delta TB equal to TB minus TB naught. Delta TB equal to TB minus TB naught, okay? Delta TB equal to TB minus TB naught, right? What are colligative properties actually? Properties of a dilute solution which depends only on the number of particles present in the solution, not on their nature, right? So experimentally it is found that delta TB, elevation in boiling point, delta TB is directly proportional to molality of the solution, that is a small letter m. Why we are taking molality? ಈಗ ನಿಮಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಮೊಲಾರಿಟಿ ಕೂಡ ಉಂಟಲ್ಲ, ಮೊಲಾರಿಟಿ ಯಾಕೆ ತಗೊಳ್ಳೋದಿಲ್ಲ? ಅಮಂಗ್ ಮೊಲಾಲಿಟಿ ಅಂಡ್ ಮೊಲಾರಿಟಿ ವಿಚ್ ಒನ್ ಇಸ್ ಟೆಂಪರೇಚರ್ ಇಂಡಿಪೆಂಡೆಂಟ್? ಮೊಲಾಲಿಟಿ ಇಸ್ ಟೆಂಪರೇಚರ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ ಅಲ್ವಾ? ನೀವು ಮೊಲಾರಿಟಿ ತಗೊಂಡ್ರೆ ಮೊಲಾರಿಟಿ ದಟ್ ವಿಲ್ ವೇರಿ ವಿತ್ ಟೆಂಪರೇಚರ್. ನೀವು ಎಲಿವೇಷನ್ ಇನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ಲೂಡ್ ಆಗ್ತದೆ ಇಲ್ಲಿ. If you consider molarity term, then molarity varies with the temperature, okay? Because molarity is temperature dependent concentration term, okay? ನಿಮಗೆ molarity consider ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. For that reason you are taking molality, okay? Because molality is temperature independent term, okay? So delta TB is directly proportional to m. We can remove this proportionality sign, then we can write delta TB is equal to one constant, that is Kb into m, okay? Delta TB equal to Kb into m. Delta TB equal to Kb into m, where Kb is called molar elevation constant. Molar elevation constant. Kb is called as molar elevation constant. Molar elevation constant, okay? Molar elevation constant or boiling point of elevation constant, okay? Molar elevation constant or boiling point of elevation constant, okay? Then when m equal to 1, that is you are taking 1 molar solution. You are taking 1 molar solution. 1 molar solution, how to prepare 1 molar solution? You have to take up 1 mole of solute in 1 kg of solvent, right? You are taking 1 mole of non-volatile solute, then you are adding that 1 mole of non-volatile solute to 1 kg of solvent, right? Then so delta TB is equal to Kb, right? Delta TB equal to Kb, right? When concentration of solute is 1 molar, then elevation in boiling point delta TB, that is equal to Kb. So now we can write the definition for Kb, right? What is Kb? Kb equal to delta TB when m equal to 1. So molar elevation constant is defined as elevation in boiling point when 1 mole of non-volatile solid is added to 1 kg of solvent, right? To take definition, in boiling point, elevation in boiling point, elevation in boiling point when 1 mole of non-volatile solute, when 1 mole of non-volatile solute is dissolved in 1 kg of solvent, 1 kg of pure solvent, 1 kg of pure solvent. That is by taking definition of molality, okay? By taking definition of molality, we can write the definition for Kb. That is because you can observe we have expression delta TB equal to Kb into m, okay? If you consider m as 1, that is you are taking 1 molar solution, then delta TB become equal to Kb. Then we can write a definition for Kb, right? Or that is how to calculate Kb. To calculate Kb, how to consider 1 molar solution of any non-volatile solute. 1 molar consider ಮಾಡಿದಾಗ you have to observe what is the value of delta TB. Okay, that is constant value. So Kb equal to nothing but elevation and boiling point when 1 mole of non-volatile solid is dissolved in 1 kg of pure solvent. Okay, what is the SI unit of Kb then? SI unit, what is the SI unit of Kb? ಇಲ್ಲಿ ಉಂಟಲ್ಲ Kb delta TB equal to Kb into M. Kb equal to ಏನಾಗುತ್ತೆ delta TB divided by M. Okay, we have expression delta TB equal to Kb into M, right? Kb into M, or Kb equal to delta TB divided by M. Okay, nothing but delta TB, temperature unit is SI unit is Kelvin, molarity is mole per kg. Mole per kg ಉಲ್ಟಾ ಮಾಡಿ ಏನಾಗುತ್ತೆ Kelvin divided by mole per kg, right? Kelvin by mole per kg, nothing but Kelvin kg per mole. Kelvin kg per mole. Kelvin kg per mole. Okay, that is the SI unit of Kb. Okay, molar elevation constant.